A circuit breaker is one of the few objects in modern life that is allowed to say no without asking permission. It doesn't warn you politely. It doesn't explain itself. It simply stops the flow and waits for acknowledgement. In doing so, it quietly prevents damage most people will never see. To understand why the circuit breaker exists in its current form, it helps to start with the problem it replaced. Early electrical systems relied on fuses. A fuse was a thin wire calibrated to melt when too much current passed through it. When that happened, the circuit opened and electricity stopped flowing. The idea was simple and effective, but crude. A blown fuse was permanent failure. Once it melted, the system was disabled until someone replaced it. If the fuse was oversized or replaced incorrectly, protection disappeared. If it blew repeatedly, people bypassed it. In many cases, the fuse protected the wiring, but not always the building. The deeper issue was not reliability. It was behavior. Electrical systems were becoming more complex, more powerful, and more widely used. People plugged in too much. They improvised. They misunderstood limits. The fuse assumed careful use. Humans did not cooperate. The circuit breaker emerged as a response to that mismatch. Instead of destroying itself, the breaker interrupts. It senses overload through heat, magnetic force, or both, and mechanically opens the circuit. Once the overload is gone, it can be reset. This changes everything. The breaker turns failure into feedback. Instead of a system that breaks and must be repaired, you get a system that pauses and invites correction. The user becomes part of the loop. Something went wrong. Find it. Fix it. Try again. This is the breaker's first major design insight. The second is that it removes judgment from the moment of danger. Electricity moves faster than humans can react. By the time you smell overheating insulation or see sparks, damage has already begun. The breaker does not wait for awareness. It acts at thresholds defined by physics, not perception. That choice reflects a clear design philosophy. Don't rely on people to notice danger in time. The breaker's physical form reflects this philosophy. It is enclosed, standardized, inaccessible during normal use. You are not meant to interact with it continuously. You are meant to forget it exists until it intervenes. The toggle is deliberately binary, on or off, no nuance, no partial states. The system either allows current or it doesn't. That clarity matters under stress. Design constraints reinforce this simplicity. A breaker must be reliable over decades. It must function in heat, cold, vibration, dust, and neglect. It must trip consistently at predictable thresholds. It must fail safely. Any added complexity increases risk. This is why breakers look conservative. They are not optimized for elegance or innovation. They are optimized for trust. The breaker also introduces a subtle behavioral shift. When a circuit trips, inconvenience occurs. Work stops, lights go out, devices shut down. This creates immediate feedback without catastrophe. Over time, users learn limits through interruption rather than damage. That learning is intentional. The breaker is not merely protecting infrastructure. It is shaping behavior. It discourages overload by making it annoying rather than deadly. It teaches boundaries through experience. This is the quiet ah-ha-ha moment. The circuit breaker is not a safety device in the emotional sense. It does not reassure. It enforces. It assumes misuse will happen and designs for it. This assumption is critical. Earlier systems trusted users to behave responsibly. Breakers assume users will push systems until something stops them. That shift marks a maturation in engineering philosophy. Instead of asking humans to adapt to systems, systems adapt to humans. The breaker also creates separation between cause and consequence. When a breaker trips, the failure is localized. The building does not burn. The wiring does not melt. The system survives. That survival matters more than uninterrupted operation. Over time, the circuit breaker fades into the background. People stop thinking about electricity as dangerous. Outlets become casual. Power becomes expected. The breaker absorbs risk quietly, allowing electricity to feel safe. This is invisible design at its most effective. The object exists not to be noticed, but to make danger boring. And when you realize that, the circuit breaker stops feeling like a switch and starts feeling like a boundary, one that exists precisely because humans are curious, careless, and creative with systems that can hurt them. The breaker does not punish. It interrupts. It does not explain. It enforces. And in doing so, it keeps modern life running by deciding silently and instantly when enough is enough.